In this lecture, we are going to solve type 3 second order linear ordinary differential equations. So which are of the form a0 d square plus a1 d plus a2 of y equal to polynomial in x. So these kinds of problems also the general solution is CF plus PI. Finding CF is like type 1 type 2 problems only. To find PI, as usual, 1 divided by the left hand side operator, polynomial in operator, that is a0 d square plus a1 d plus a2 into, let it be p of x. Okay, the polynomial in x be p of x. Then bring this constant outside. So 1 plus a0 d square plus a1 d by a2 into p of x. Now bring this to the numerator, which is equal to 1 by a2 into 1 plus a0 d square plus a1 d by a2 whole power minus 1 into p of x. Before that, we should know the binomial series formula, that is 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube plus x power 4 and so on. Similarly, 1 minus x whole power minus 1 is 1 plus x square plus x cube plus x power 4 and so on. Similarly, 1 plus x whole power minus 2 is 1 minus 2x plus 3x square minus 4x cube plus so on. 1 minus x whole power minus 2 is 1 plus 2x plus 3x square minus 4x cube, plus 4x cube and plus so on. Now, using 1 plus x whole power minus 1, we can expand this thing. So this we can expand, then bring that polynomial inside this bracket, then solve it, then we can get the particular integral. Suppose a0 is 0, then what you may get? Suppose this a0 is 0, then you may have pi is of the form 1 divided by a0 d square plus a1 d into p of x. So which is equal, these kinds of problems we can solve. Bring this a1 d outside. 1 divided by a1 d into 1 plus a0 d square by a1 d into p of x. So now bring this to the numerator, then you can expand like 1 plus x whole power minus 1. Then bring this polynomial inside. Then we can proceed like previous case. And for this 1 by d, so we know that d is d by dx. So 1 by d is nothing but integration with respect to dx. So 1 by d means integrate. We need to integrate the resultant. Okay, so like that we have to proceed. So we will solve some problems, then we can know in detail. So write the problem. D square plus 5d plus 6 of y equal to x square. Now first find the CF. For that, first write auxiliary equation. So auxiliary equation is m square plus 5m plus 6 equal to 0. So this is nothing but m plus 2 into m plus 3 equal to 0. Factorize it. Then m is nothing but minus 2 comma minus 3. So here the roots are real and distinct. So the complementary function is c1 e power m1x plus c2 e power m2x, where m1 is minus 2 and m2 is minus 3. If you substitute, then you get c1 e power minus 2x plus c2 e power minus 3x. Now find pi. So pi equal to, for all the three types, pi is of this form, 1 divided by, write the polynomial in D. That is the given problem. In the given problem, write the left hand side without y. So d square plus 5d plus 6 into x square. Now bring this constant outside, then only we can get 1 plus form. Then we can apply binomial expansion. So which is equal to 1 by 6 into 1 plus d square plus 5d by 6 into x square. Now bring this to the numerator. Then what you may get? 1 by 6 into 1 plus d square plus 5d by 6 whole power minus 1 of x square. So which is equal to 1 by x, 1 by 6 into, it is like 1 plus x whole power minus 1. 1 plus x whole power minus 1 formula is this one. 1 minus x plus x square minus x cube plus x power 4 and so on. Alternatively plus minus, and power of the x will be increased. So like that here you treat this whole thing as x. So 1 plus x whole power minus 1 is 1 minus d square plus 5d by 6 plus d square plus 5d by 6 the whole square and so on. Before that, d means differentiation. Now d x square is what? Dx square is 2x. Differentiate x square with respect to x one time. So d square x square means what? You differentiate x square twice. So one time differentiation is 2x. Once again, if you differentiate, then you get 2. Then d cube x square is 0. So from d cube onwards, it is 0. So that you no need to write the whole cube form, because here only we get d square form. Afterwards the minimum power itself d cube. So we can stop up to this term. So now into x square is there. So which is equal to 1 by 6 into 1 minus 1 by 6 d square minus 5 by 6 d, and it will go on like this. Then what you may get? Plus, so here if you expand like a plus b the whole square, then this term is a square. So d square whole square, it is d power 4. Here d cube itself 0, so d power 4 is obviously 0. So we can omit that a square term. And then plus 2ab. 2ab also here d square is there, here d is there. So if you multiply, then it is 5d cube into 2. So d cube of x square is 0, because here the polynomial is x square. So if you differentiate x square thrice, then it is 0. So we can omit that term also. So only b square term we have to consider. So that means 5 by 6 into d the whole square. So that is 5 by 6 d the whole square. And the series is infinite plus so on into x square. Now if you bring x square inside, then what you may get? 1 by 6 into 1 into x square minus 1 by 6 d square x square minus 5 by 6 d x square plus 25 by 36 d square x square, and plus so on. Now which is equal to 1 by 6 into x square minus 1 by 6. So d square x square. So dx square is 2x, d square x square is 2. So you can substitute that 2. So 2 minus 5 by 6 dx square is 2x, and then plus 25 by 36 d square x square is 2. Now if you simplify this one, then which is the required solution of the given differential equation. Now we will see the next problem. So next problem is solve d square plus d of y equal to x square plus 2x plus 4. Now the auxiliary equation is m square plus m equal to 0, that is m into m plus 1 equal to 0, that is m equal to 0 and minus 1. So here also the roots are real and distinct. So CF is of the form C1 e power m1x plus C2 e power m2x. So which is equal to C1 e power 0x plus C2 e power minus x. So which is nothing but C1 e power 0x is e power 0, e power 0 is 1. So C1 plus C2 e power minus x, which is CF. So now find PI. PI equal to 1 divided by d square plus d. Write the left hand side of the differential equation without y into x square plus 2x plus 4. So which is equal to 1 by, now here constant is missing. So we need to write in the form of 1 plus. Okay, so that we can apply the binomial expansion. So d into 1 plus d into x square plus 2x plus 4. So which is equal to 1 by d into 1 plus d whole power minus 1 of x square plus 2x plus 4. Now 1 by d into, so if you write like 1 plus x whole power minus 1, then what do you get? 1 minus d plus d square minus d cube plus so on of x square plus 2x plus 4. So now bring this polynomial inside, then what do you get? 1 by d of 1 into this polynomial, that is x square plus 2x plus 4 minus d of x square plus 2x plus 4 plus d square of x square plus 2x plus 4. And this is a second degree polynomial. If you differentiate thrice, then that will be 0. So we can omit the other terms. So 1 by d of x square plus 2x plus 4 minus d means differentiation with respect to x. So differentiate this polynomial with respect to x, then what do you get? 2x plus 2 minus, if you differentiate twice, then what do you get? Simply 2, because differentiation of x square twice is 2, and differentiation of this twice is 0. So simply you make it this one. Now which is equal to 1 by d of x square, here plus 2x and minus 2x get cancelled, then this 4 and this minus 4 also get cancelled. Simply you get this one. So the one d is differentiation, 1 by d is integration x square dx, so which is equal to x cube. While you are integrating, to find the particular integral, we should not add integration constant. So particular integral is independent of constant. So pi is x cube. So general solution is cf plus pi. So which is equal to cf is what? Cf is c1 plus c2 e power minus x. C1 plus c2 e power minus x, then plus pi is x cube. That's all. This is your required solution. That is y equal. Thank you.